What does a bird and a sonic boom have in common? Reaching speeds of over 320 kilometers per hour, every time the Shinkansen train speeds into a tunnel, they would basically become a shotgun round. And, every time the train would blast out of that tunnel, it did so with an incredibly loud bang. It's called tunnel boom, and is created by the train forcing air along the enclosed tunnel, and building up the air pressure in waves until it reaches the end of the tunnel when it is released in the form of a sonic boom. Angered by the noise, local residents reported hearing bangs up to 400 meters away from the railway. Then in 1994, an engineer, named Eiji Nakatsu, discovered the solution thanks to his hobby of bird watching. He gained inspiration from the kingfisher, which dives nose first into water to catch fish and barely makes a splash. Nakatsu gave his train a 50-foot steel beak which solved the noise pollution problem. It also made the Shinkansen train between about 15% more efficient. If you receive a painless injection from a new microneedle in the near future, you may owe a debt of gratitude to the mosquito. The reason why is because, quite possibly everyone's least favorite insect, is the inspiration behind new work being carried out by researchers. The reason we look at nature for clues is because nature has been through so much evolution to discover the simplest and most efficient methods. Part of what makes mosquitoes so good at getting humans sick, researchers are now learning, is the effectiveness of that bite. Researchers are taking a much closer look at the unique components that enable the mosquito to bite people without causing them discomfort. The mosquito uses a combination of four things: a saliva-based numbing agent during biting, a serrated design for the needle, vibration during the piercing process, and a combination of soft and hard parts on the proboscis, the insect's elongated sucking mouth part. This is nature's method, and the combination allows the mosquito to pierce the skin with just 1/3 of the force required for an artificial needle, while the numbing agent takes care of the rest. In 2011, a hypodermic needle was developed in Japan, that patients claim is virtually painless. This is important as approximately 10% of Americans suffer from a fear of needles, which may prevent them from receiving vaccines, blood tests or other treatment such as dental care. Once these new needles were proven effective, another group within the healthcare system realized that it could be used to provide safer and more effective treatment. Neurosurgeons use a neurosurgical probe to remove brain tissue in some selected patients. These are just a few examples of how the biology of the mosquito has been used to help millions of people. Many modern aerodynamic designs rely on basic principles. To obtain optimal lift and minimal drag, sleek edges and clean lines are key. However, throughout the animal kingdom, many species are capable of exceptional lift. For example, the humpback whale uses bumpy, tubercle fins for propulsion. This seems counterintuitive. Tests conducted by the U.S. Naval Academy, using model flippers, determined these biomimetic fins, reduced drag by nearly 1/3 and improved lift by 8% overall. Whale Power, a company based in Toronto, Canada, has already capitalized on this latest amazing tech. According to MIT, Whale Power's biomimetic blades help generate the same amount of power at 10 miles per hour that conventional turbines generate at 17 miles per hour. Sharks are one of the apex predators of the seas. Their hunting prowess has been fine-tuned over millennia. While sharks are well known for their acute sense of smell and regenerating teeth, new research may actually point to the species' skin as its most evolutionary asset. Shark skin is covered with so-called dermal denticles. When in motion, these dermal denticles actually create a low-pressure zone. This leading-edge vortex basically pulls the shark forward and reduces drag. Speedo notoriously incorporated biomimetic shark skin into a line of swimsuits for the 2008 Olympics. The technology has since been banned in Olympic competition. Access to water is pivotal to any sustainable civilization and life on this planet in general. Some arid climates must make do with limited precipitation. Technology derived from a beetle thriving in one of the harshest environments on Earth may very well help start the next generation of clean water harvesting. The Stenocara beetle lives in the arid African Namib Desert, but the tint critter has an evolutionary hack to help it pull water out of literal thin air. A pattern of nodes along the beetle's back enable the creature to pull moisture from the fog. The droplets then slide off the bumps into small channels towards the beetle's mouth. Scientists are now using this research to develop biomimetic patterns capable of harvesting water from the air. Woodpeckers are known for their amazing excavating capacity. The creatures use their beaks to forage for insects and also to create places for themselves. As woodpeckers bore these holes, they experience 1,200 Gs, nearly 22 times per second. To put that in perspective, a severe car crash would deliver the equivalent of 120 Gs on a passenger. Just how does the woodpecker withstand these perpetual jolts? The answer lies in natural shock absorbers. Woodpeckers have 4 structures designed to absorb mechanical shock. The bird's semi-elastic beak, an area of spongy bone material behind the skull, and cerebrospinal fluid all work in unison to extend the time over which this concussion occurs and therefore inhibiting vibration. Based on this complex design, researchers are working to create several applications ranging from more shock-resistant black boxes to spacecrafts. Squids, like all cephalopods, are capable of bioluminescence, as well as changing their skin color. This camouflaging capacity allows them to hide from predators while the bioluminescence allows them to communicate with and to attract a mate. This complex behavior is produced by a network of specialized skin cells and muscles. Researchers have developed a similar device capable of detecting its surroundings and matching this environment in mere seconds. This early prototype uses a flexible, pixelated grid utilizing actuators, light sensors, and reflectors. As the light sensors detect a change in the surroundings, a signal creates heat in the area, thus changing the color. This artificial skin could have both military and commercial applications in the future. Let's take a look at termites. Termites are known for creating some of the most elaborate ventilation systems for cooling on the planet. Even in some of the hottest places, these termite mounds remain very cool inside. Using a complex network of intentional air pockets, the mounds create a natural ventilation system using convection. Engineers in Zimbabwe built an entire shopping center based on this natural convection system. Currently the system uses 10% less energy than a traditional air-conditioned facility. George de Mestral was inspired to invent Velcro after noticing how easy it was for burrs to stick to his dog's hair. Upon studying them under a microscope, he noticed the simple design of tiny hooks at the end of the burr's spines. These were able to catch anything with a loop, such as fur and fabric, and he went on to replicate this synthetically. His 2-part Velcro fastening system uses a strip of loosely looping nylon, opposite a strip of tiny hooks, and has since been prolific in its range of applications and popularity. Perhaps one of the most famous examples of biomimicry is evident in the history of human flight. Leonardo da Vinci is largely known as a key figure in its development. His original design, called the ornithopter, was never created, but was a principle in showing how man could potentially fly. Several designers and engineers worked on this bird-inspired concept in the following years. For instance, Otto Lilienthal completed more than 2,500 flights in a glider, but it was not until 1903 that the Wright brothers flew the first powered, heavier-than-air machine in a controlled and sustainable flight. This technology went on to define the aerial developments of 20th century and the technology seen in the air today.